Hey guys, this is Mrs. Gephardt, and I'm going to go through some videos reviewing the content that was covered on the study guide. And I did 4 different videos, and they're kind of different and done in different ways. But I decided to break it up by topic, so you can see this is video 1, and it is going to be covering questions 2 through 9. I broke it up into surface water and groundwater because they are related to each other. So that's what this video is. And once you're done with this video, you can go preview the other videos, which will cover all the other water content that is on the study guide. All right, so when we look at this, question number 2 is asking where all the fresh water on the earth is. And you have to understand that when we think of the fresh water on earth, it's locked away. It's in ice. So I know that sometimes we might think, oh, it's in groundwater. Well, no. Okay, all of the water on the earth that is flowing in the rivers and the lakes and the streams, in the groundwater, that makes up a very small percentage of the actual fresh water. Most of our fresh water is trapped in the ice. Okay, so just kind of keep that in mind when you're thinking about where is the fresh water. Okay, next question is talking about, so we have this fertilizer, and we know that a fertilizer is what your parents would use if they're, got a garden or they're trying to make their roses grow or something like that. It's going to promote growth. Well, algae, right here, algae is a plant, so algae is going to grow if there's fertilizer. Well, fertilizers are going to help promote it. Where are those fertilizers coming from? Okay, and they're coming from the farms and the houses. They're coming from us. Okay, and we can kind of rope this all together as runoff. Okay, so we can kind of say all this runoff is going to be causing all of that fertilizer to, it's going to run off, it's going to carry it all down to a river or a lake or a stream or whatever. And from there, that's going to lead to the growth of this algae, an excessive growth of this algae, because the algae is going to grow. We're just making it grow faster and grow more. Okay. Question number 4 is talking about an aquifer. So we want to know what an aquifer is, okay? And an aquifer, we have to think about it, it is the rock itself, okay? It is a layer of permeable rock. And let's remind ourselves, permeable rock is rock that has spaces. So we can imagine pebbles, we can imagine even sand. Sand is permeable because if I were to pour sand in a cup and then I poured water in that cup, water would be at the bottom of the cup. So that means it has passed through all of that. So the ability to pass through it is permeable, okay? And a lot of times people are going to drill their wells right into the aquifer, and that's where they're going to get their water supply, okay? Because they're going to go right down into the ground and they're going to pump the water out. So that's permeable rock. Number 5 now, when we think about that aquifer, what is required to have it form, okay? So in order for an aquifer to form, first off, there has to be some kind of permeable rock that actually is holding the water, okay? So there's going to be some kind of rock, soil, something that's holding that water in place and allowing it to sort of sit in those gaps. The second thing is there's going to have to be some kind of layer of impermeable rock and we kind of want to think of it like a cup, something almost at the bottom. So if I have all this water, something's got to stop it right here. So this is permeable rock in here. I know my hand's not really, let me see. There we go. I'm trying to make my hand look like this. This is impermeable rock. All this up here is permeable rock. Okay, and it's holding all the water, but there has to be a place that the water isn't going to go any further, because if it was all just completely permeable, the water's going to spread everywhere. Okay, there's nothing that's stopping it. So it's like if you wanted to drink orange juice, are you going to dump orange juice across your table and lick it up because the orange juice is going to spread out, or are you going to put the orange juice in a cup? If we put it in a cup, it's restricted into a certain area. Same idea with an aquifer. The other crucial thing with an aquifer is that we're going to have some kind of supply of water that replenishes that aquifer. So we have to think about it in terms of what's keeping it going, okay, which is going to be probably likely rain, okay, some kind of amount of rainfall. So in very rainy regions of the world, we're going to, especially in a monsoon or a ton of rain, we could see aquifer levels rise and be really full of water. But we have to be very careful that we don't pull too much water out at a higher rate than we're putting it in, because if we do that, then we're going to have a water shortage. Okay. All right, the next question, well, this one's not a toughie. What is groundwater? Okay, groundwater is really literally completely covering every bit of water that's found underground. That is groundwater. So it doesn't matter if it's at the tippy top, If it's all the way to the bottom, doesn't matter where it is. If it's water that's underground, it is considered groundwater. Okay, that's literally its definition. Okay, number 7, impermeable rock, and this is important. Impermeable rock is going to be any rock, and we can think of rock like granite, okay? So you can think of a granite countertop or something like that. But this is rock that will not allow the water to pass through it. So that's back to my reference when we think about a juice glass. So if I have a little juice glass, oh sorry, my juice glass is a little warped, and I put some juice in it, okay? This down here, right there, that is making it impermeable. That juice is not going to be leaking out of your cup, and if it does, I suggest you get a new cup because that's going to kind of defeat the purpose of a cup. Same idea with impermeable rock. It's holding the water in place so that the water, because otherwise if it didn't, the water would just keep going and keep going and keep going, and that would not collect anywhere. We want it to collect somewhere so we can get it out. Question number 8. So what is the water table? And the water table is the highest level of water underground. And that can change, okay? It can change depending on seasons. It can change depending on our usage. In some parts of the country, in some parts of the world, there's a lot of agricultural use. So people are pulling a lot of water from the ground to water plants, to water crops and things like that. So that water table can vary, okay? But if we think about it, the water table, so if this is a portion of underground, okay, this could be water sitting right here, and that's the water table. And maybe this is in, we'll say, the spring, okay? We can then have that same portion of underground, but now it's down here, and maybe it's in the fall. I'm just making up arbitrary times. It doesn't, spring or fall, it'll depend on the region as to the waterfall. But this would be the water table in the spring, and this could be the water table in the fall. Okay, so it really doesn't matter. It's just the highest level of water at that time underground. All right, question number 9, and this is the last question. That water table, and kind of talked about it with the previous one, it really depends on the amount of precipitation. And then, of course, just like the aquifer levels, the water table is going to vary depending on how much rain happens, but also how much we're pulling out. All right, so if we're really using a ton of water to water a lot of crops, and that happens. I mean, think about cornfields and things like that. They're huge. That's going to draw a lot of water out. If we are pulling at a greater rate than is being replenished, then we're going to have a problem, and that water table is going to be very, very low. And that's when it starts to get really scary. I know it seems very good for us because we always seem to have water, but remember, there are parts of this world that do not have that, okay? So we all have to be, conservative, and I know that you guys are learning those terms, water conservation and such, but we have to be careful at how quickly we pull, because if it doesn't have time to replenish, then we can run into a water problem. And remember, when it rains outside, that water that hits the ground isn't going to go bam right into the water table. It takes time. It takes time for that water to sort of trickle down into the ground. Okay. This is the end of the first video, so please make sure that you, if you have any questions, you ask your teacher. If you would also go visit the other videos and see all the other questions, and if you have any questions on any videos, ask your teacher, and hopefully this was helpful, and I will see you in the next video.